Hello, I am Edward Berman, and I am going to be talking to you about how to count the number of ways of selecting k objects from a collection of n distinguishable objects without replacing them and where order does not matter. We are first going to contextualize this. We're going to give it a definition, or rather a formula, and then we're going to motivate our definition, do an example, and then we're going to make connections and summarize. So when we ask how to count k objects from n distinguishable objects, we're asking questions in the manner of 6 cards from a deck of 52, or how do we shoot off 3 light switches from a set of 20. So formally, this is how we define how to do this. It's n factorial over k factorial times n minus k factorial. And informally, it's a number of ways we can choose k boxes from n elements without replacement divided by the number of ways you can order these k boxes. It'll be more tangible once we go to this example. So for example, we have 18 boxes here, and we want to find out how we can pick 3 of them without replacing them where order doesn't matter. So here's a question. How many choices do we have for the first one? Well, there's 18, so we start by choosing 18. Choose one box at random and repeat. Now I have one less choice, so now I have 17. And I want to choose 3, so I have one more choice, so I choose 16. So this is equivalent to 18 factorial over 15 factorial. As you can see, it's 18 times 17 times 16. And then instead of 15 all the way down to 1, we just divided that right here. So why the k term? Well, for each way you can select k elements, in this case 3, there are k factorial ways of arranging them. So there are k factorial ways of choosing the same k elements, and we only want to count each outcome one time. So we have to divide by k factorial. As I've written here, we don't want to count green, then red, then blue, versus blue, then red, then green as distinct outcomes. We only want to count each one once because we are trying to count the ways where order does not matter. So if we plug that equation here, we find that there are 816 ways to choose 3 boxes out of our 18. One thing to note that this is essentially the formula for selecting k objects from n distinguishable items without replacement or where order matters, with an extra term, with an extra k factorial term to correct for order. So all I've done today was I introduced what we were talking about. I gave an example with a deck of cards. I gave a formal definition, and then I went through this example.